Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on the sine rule. So the sine rule allows us to use trigonometry to find unknown sides and lengths in non-right angled triangles. So this works for non-right angled triangles. So first thing we need to look at labeling sides and angles. So let's say we have a triangle like this, clearly a non-right angled triangle. So we're going to label the sides A, B, and C. It doesn't matter which side you call A, which side you call B, which side you call C. So in this case, C doesn't have to be the longest side. So I might call this side A, this side B, and then this side C. Now, what's important when you're labeling them? We use small letters for sides and large letters for angles. That's just the convention. So if the question says find big A, it's talking about an angle. If it says find small a, it's talking about a side. So big A needs to be opposite small a. So big A would need to be this angle here. And then this would be angle C and angle B. Okay? So angles with the same letter are opposite each other. It's important we label it like that so that the rule works. So the sine rule states that the ratio of each side to the sine of its angle is equal. As an equation, it looks like this. So this is the rule, and this is the equation that we will use to find unknown sides and angles. Now, just so you know, most people find it easier to use this sort of rule when they're finding a side. Most people find it easier to flip it when we're finding an angle. So you can decide whether you just want to learn this rule or you want to learn that you flip it for an angle. You can use this one to find an angle. It's just people find it easier to use this one. All right, let's look at some examples. So obviously you need a certain amount of information to be able to use the sine rule. So if I want to find side A, for example, I need to know its opposite angle. And I need to know another pair of sides and angles. So let's look at an example where I know this. So let's use the sine rule to find x in this triangle above. So of course it doesn't matter whether I call it x or a or whatever. So x can be sort of my a over sine of its angle. So remember, angles and sides come in pairs opposite each other. So that is equal to b over sine B. So this is just an equation to solve. Sine 28 is just a number. It's an irrational number, but a number nonetheless. So in order to get x by itself, I just times each side by sine 28. So it's 44 sine 28 over sine of 108, and I'm just going to put that in my calculator. And the answer I get to two decimal places is 21.72, and of course it will be centimeters. So again, you need to make sure your calculator's in degrees mode or you'll get the wrong answer. So one thing we should note is that in any triangle, whether right angled, scalene, or whatever, the longest side is opposite the largest angle, and the shortest side is opposite the smallest angle. So of course in this triangle, because 108 is opposite 44, 108 is obviously bigger than 28, x should be smaller than 44, right? Because this is the largest angle, so this will be the largest side. So because our answer is less than 44, we know we've done something right. Let's look at another example of finding a side. Please pause and copy this down if you need. So let's try and find the value of x in this triangle here. So we have a side and its opposite angle, but the side we want to find, we don't have its opposite angle. But fortunately, that's really easy to find. This angle here will just be 100 minus 95 minus 18, which is 67 degrees. So now we can use the sine rule. Side over its opposite angle, or the sine of its opposite angle, equals side over its opposite angle. Once again, I can solve this by just timesing each side by sine 67. because sine 67 is just a number. I put that in my calculator, making sure that my calculator is in degrees mode, and the answer I get this time is about 20.85. So just a quick check. Of course, this angle is larger than this, so x should be larger than 7. It is, so I know I've done something right. Now let's look at finding an angle using the sine rule. So let's now look at using the sine rule to find the angle C in this triangle here. So remember, when you're trying to find an angle, it's usually easier to flip the sine rule so that the sines are on top. So sine of angle over corresponding side equals the sine of angle over corresponding side. So I want to get C by itself. So once again, like in the previous example, I'm going to times by the denominator of the fraction. So I get sine C is 18 sine 50 over 16. Now to get C by itself, I take the sine inverse of both sides. So this will be the sine inverse of 18 sine 50 over 16. So make sure everything is contained within the brackets. If you try to take the sine inverse of something more than one, your calculator will return an error. So putting this on my calculator, making sure it's in degrees mode, I get 59.5 degrees, okay? So C is 59.5 degrees. Now that makes sense, right? Because 18 is longer than 16 by a little bit, so this angle here should be a little bit more than that, which it is, okay? And thus, we are done. We have found the angle. All right, thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.